Continuation of lab 1, and in this video we are going to see on how to simulate this circuit. And in this circuit we can see that we have A, P, C, T, 4 inputs. R and S are SiC wires, and that connects the output of AND to the input of OR, and output of AND to the input of R, and the output pin where we are going to take the output from. And as we know that the basic structure of vhdl, first instantiate the library files, include the library files, and then the basic structure, I'll remind it to you again. Entity, project 2, name of the project is port, declare all the ports here. As you can see that A, B, C and D are input ports, and O is the output port. That's declared over here. I just don't want to write it again here. And end entity, and after that architecture behavior of project 2 is, and then end behave. And we have the logic in between what I wrote here. And one thing to keep in mind when writing a vhdl code is when you declare a signal, always declare it between A, we don't need this anymore, always declare a signal between architecture behavior and begin. If you declare it after begin, your vhdl is going to pop you an error. And let's see the simulation of the program now. Once again, let's go through the program. This is the entity. Project 2 is port. A, B, C, D are the input ports, and output is the output port. Only ports are declared in entity. Okay, and after that we are starting the logic here. Architectural behavior of project 2. We are declaring two signals R and S, as the diagram shows that we have two signals that connects two blocks to a single block. And process is ABCD because ABCD are the inputs. Begin, this is an error. R is A and B, and S is C and D, and output is nothing but R or S. And we are ending the process here and ending the behavior logic. And now this has to work. It's taking some time to synthesize, so let's give it some time. No, it's showing me some errors in the code. Okay, let's see what are the errors. Syntax error near this. Okay, and I think that should be it. That doesn't matter, you can ignore that error. If you want to ignore that warning, just put R and S in the sensitivity process and your warning should go. And let's try to see the schematic, Rtl schematic of the circuit. And A, B, C, D are inputs, and then O is the output. This is R, this is S, and this is R that connects output of the AND gate to the OR gate, and this is the output. And let's try to simulate the circuit now. And as we can see that from the diagram, if A is 1, B is 1, R is 1, if C is 1, D is 1, S is equal to 1, and R or S is nothing but 1, because 1 or 1 is nothing but 1. And let's see the other test case, that is this one. So AB is 0 0, CD is 1 1, AB is 0 0, CD is 1 and 1, 0 and 0, r is equal to 0, s is equal to 1, r or s is nothing but 0 or 1, which is nothing but 1 is the output. So the output is also correct. Now let's try to do some errors in the program and try to correct those errors. And one error which I'm going to do right now is take the signal out from here and put it after begin. Let's see what happens. Rerun. And definitely vhdl is going to pop up an error saying that r and s are not declared. So, and standard underscore logic is not a component. So the lesson here is that never declare a signal after begin. You have to always declare a signal before begin. Always declare signals before begin. I'm telling this twice because people do mistakes and vhdl pops you an error. And now the error should go. Yes. And it has to synthesize again. And in this video we're also going to have the discussion of variables and what's the difference between a signal and a variable, and why should you not use a variable in the vhdl programming language. And this is all about it. And now let's try to use a variable inside a program. Like signal, a variable should always be declared. A variable should always between process and process begin. When I say process begin, I mean this begin. So I have declared two variables r and s, and in my opinion this should also synthesize because it is specified to this process and r and s are the part of this process. Okay, so the thing is I cannot use this symbol to assign a variable, it is this, and it has to work well now. And yes, it is going to synthesize. R is not declared. Strange. Just a minute. Let me take out the sensitivity parameters from here and let's try to do this. And it did synthesize, and we got a wires here, and the output should be the same one again. But the discussion is about why should we not use a variable. Let me simulate this. Let me pause it for some time. The same output again, a1, b1, c1, d1, the output is 1. A and b is 1, r is 1, s is 1, and r or s is nothing but 1. So why did I say that it's not a good habit to use a variable? So yeah, so let's start it now. So, and now if I have to connect this to an adder that we have designed in the previous class, I'm going to use a port map. We will discuss port map in the next lecture. So if I have to connect this, to an adder, I'm not so good at paint, so please cooperate with me. If I have to connect this to an adder, R adder, and take the output 2 from the adder. I'll draw a neat circuit diagram and then show you. Just hold on for a minute. So this is a circuit diagram we have to design. This is going to be R and S. Oops. And the same R and S should be connected to the adder. And let's see what happens. So I'm just going to edit this code by a small margin. I'm just going to put output 2. Output 2 is nothing but out standard underscore logic, and I'm going to port map here pp1 port map, and what is the name of our file? It's adder underscore new. Addr underscore new. And while performing a port map, you have to always be sure to instantiate the component before doing it. Instantiation of the component should be done before begin. I'm going to do that now. So this should be component. We will discuss this in the port map and why should this be done. For now, let it stay like this. Always component have to be declared if we are reusing it from another file, and the component declaration has to be between architecture behave and begin. Okay, I started a component. Always the component have to be declared if we are using it from the another file name, which is nothing but adder underscore new, and the component declaration has to be between the architecture behavior and the begin. If you declare the component after begin, vhdl is going to pop up an error, and we will see that in the port map. But coming on to a discussion of variables, we have A, B, C, D, right? Now A tends to R, B tends to S, C in is 0, and C out is going to, no, we don't need a C out anyway, and C tends to TPUT2. So let's run this program and see. And in my opinion, vhdl should pop up an error saying that R is not declared. Oh, why is R not declared? R is not declared because the variable is only specific inside a process. Once the process ends, your program vhdl cannot know what is R. R and S are only available inside the process. Once you go out of the process, R is not available, or R is not recognized by the vhdl. So let's try to change this program and put a signal, and the code should work fine. And let me just copy paste it. It's a bit slow. Observe that I took out a variable here and put a signal here, and the code synthesizes fine. It's because once you declare a signal, the signal is common to what you write in the program. You can use a signal anywhere. If I'm writing another adder or a multiplier, I can use that argument as there also. So that's the difference between a signal and a variable. Variable is only defined to a process. Variable is only defined to a process. And that's the reason why the variable should have to be avoided in vhdl. And let's view the Rtl schematic of this, and you can see that our new component adder, which we have created in the previous lab, is being instantiated here, and that is done using the port map. And we've currently discussed about the difference between the signals and the variables, and that's it, guys. And in the next class we will see about the port map, if else construct, and the case construct. And then I'll post this code online, and you can try to run this code in your computer and analyze the output, and that's gonna be your homework. Try to analyze the code, and that's all for today. Have a great day.